So let's look at some examples of writing complex numbers in their modulus argument form. So for the first one, 3 plus 4i. So if we, again, draw a quick diagram just to see where it is. So the point 3 plus 4i is in that point, in that position. So we go across 3 up 4. So our modulus there will be a distance away from the origin, which means it's going to be 5, because square root of 3 squared plus 4 squared is equal to 5. So the modulus of z would be 5. So that's where we're getting that idea. And you can see it's a 3, 4, 5 triangle. So it makes sense there. The angle there is going to be inverse tangent of 4 on 3. So tan of theta is 4 on 3. Theta is 53 degrees, then approximately. It's going to be an approximation. If you want to do an approximation, that's okay. It's not a problem at all. So taking note that's in the first quadrant, it's just going to be 53. So we write 3 plus 4i is 5 cos 53 degrees plus I sine 53 degrees. We want to write it in the modulus argument form, or if we want a shorthand way of writing it, 5 is 53 degrees. So the next one, minus 2 plus 2 root 3i, which puts it in the second quadrant. So go across minus 2 up 2 root 3, apply the square root of the numbers, all sum of them squared, gives you 4 as the modulus. Tan theta is equal to minus root 3, so it's in the second quadrant, so it's going to be inverse tan of minus root 3 in the second quadrant would be 180 minus 60, which gives us 2 pi on 3, which I can write as 2 pi on 3. So that's pi on 3 there from our inverse tan of pi on 3, and so we get our related angle. What in the second quadrant it would be pi minus 2 pi on 3. Write it in radians or degrees. It's up to you. It's no big a deal otherwise. 1 plus I. So where's 1 plus I? Look, 1 plus 1 there and 1 there. So 1 plus I is there. So our modulus would be root 2. So inverse tan of 1 would be pi on 4. So we get root 2 is pi on 4. 1 minus I. So we're going across 1 and down 1 there. So it's going to be in the fourth quadrant. Again, same modulus. So, and the argument would be pi on 4 in this direction. So it'd be 7 pi on 4. So we can write it either way here. I've written it says root 2 says 7 pi on 4. But with it, if we wanted to put it in with its principal argument, technically we'd have to write it as root 2 says minus pi on 4. Same position, 7 pi on 4 and minus pi on 4 are in exactly the same position. It's just one rotation around in either direction from each other. So, but that would be where we put in our principal argument, because it's between minus 180 and 180. So take note of that. If it doesn't say, well, you can put whatever angle you like, but if it wants a principal argument, it's got to be between negative 180 and 180. So minus 1 plus I, so across 1 up 1 there. So again, our modulus is root 2, and inverse tan of 1, well, we know that's going to be 45 or pi on 4. So the angle there would be 135 because we're in the second quadrant there. So keep it in mind. Minus 1 minus I, so obviously in the third quadrant. So we've gone across and then down to get our point there. So across minus 1, down minus 1. So it's going to give us a distance of root 2. And going to be positive, but it's in the third quadrant. So it's going to be 180 plus pi plus 45, or pi plus 5 pi on 4. So root 2 says 5 pi on 4. Or if it's going to be in its principal argument, it's going to be back to minus 3 pi on 4. You're back in the third quadrant is going to be between negative pi on 2 and negative pi. Question 5, 1 plus root 3i. So again, square root of 1 squared plus root 3 all squared. That gives us 2. And inverse tan of root 3 on 1. We're in the first quadrant. It's just going to be that principal argument. So 2 is 5 pi on 3. 1 minus 1 minus root 3i. Again, substitute those values into the square root of the parts squared there, and that gives us 2. Tan theta is going to be inverse of root 3 minus root 3 on minus 1, and we can see it's in the third quadrant, so we get 4 pi on 3, and big from pi plus the pi on 3. So there, that's 2 cis 4 pi on 3, or 2 cis minus 2 pi on 3 with the principal argument. 2 minus root 3, so minus 3i. So we substitute in, we get root 13 as our modulus. Leave it in its irrational form there, like that. It's going to be exact there. Inverse tan of 3 on 2, well, that's going to give us 56 degrees. So we're going to be realise we're in the fourth quadrant because we've gone across and down. We're positive then negative there, so it's gone down. So we're in the fourth quadrant for that. And so that would give us an angle of 304 or minus 56 degrees. So as a principal argument, minus 56. So you could write it either way. I'd be quite happy to see it either way, unless otherwise told. 1 plus I on root 2, we can split it up to be 1 on root 2 plus 1 on root 2 times I. So we do our substitution to get our modulus of 1. And inverse tan of 1 gives us pi on 4, so that's just going to be 1 cis pi on 4, or just cis pi on 4, we can write it like that. Question 9, again, split this up, and so we get root 3 on 2 plus a half I. Do the substitution, we get 1 as our modulus again, and we're in the fourth quadrant because it's positive real and then a negative imaginary number, so we've got in the fourth quadrant. Inverse of 1 on root 3 would be pi on 6, so theta is equal to 11 pi on 6 in the fourth quadrant, or minus pi on 6. So that would be our position, our angle there. What about just minus 4? What would that give us? Well, if you look there where minus 4 is, it's just on the imaginary, on the negative real axis. So what's the distance? Well, if we put that in there, we can show that it's equal to 4. It's not really too hard to work out the distance. There would be 4. But what's the angle there? Well, tan of theta, inverse tan of theta will give you an idea that it's either going to be either 0 or pi or a multiple of those. So it's going to be on the negative x-axis, which means we know that that is a position of pi. So that's where we're going to get pi. We don't really need to do too much calculation there. We know where it exists. So we can write that as 4 cis pi. We don't write it as 4 cis negative pi because the principal argument is between negative pi, but not including negative pi, to pi plus, which is pi's included in that part. So there's how we put numbers into complex numbers into modulus argument form. Take note, you're going to get a number out the front, and then you're going to get that angle, and that's how we're describing it, through a position and idea of how far it's going to go and at what angle it is around the 360 degrees.